That's fantastic. So everything that happened so far, everything that I was talking, I was muted. That's number one. Okay, so welcome everyone who just joined the stream. Yeah, if you have any questions, add them to the chat on the right-hand side of the YouTube stream. If we have time, we're going to answer questions. If not, we're going to ask speakers to answer questions later. Yeah, you see the agenda on the screen. So now we are moving to this really quickly, shortly introductory part where I'm representing PyLadies Amsterdam and Kali and Dana are representing PyData Amsterdam. So floor is yours for a couple of minutes and then I'm moving forward. Yeah. Yes.
So thank you everyone for joining us today. It's always a pleasure to partner with PyLadies to organize this amazing meetup. Yeah, so about the PyData Amsterdam, we are a community here in Amsterdam, and we try to monthly have meetups, and we bring topics about data and open source tools, especially for Python, R, and Julia, but mostly Python. And yeah, it's super nice to have this collaboration. Yeah, I think that's it for now.
Yeah, we're really looking forward to this meetup. I think I'm personally really excited about gaming, as I came to technology through the gaming. So I think everyone else is excited with me.
Yeah, good. Thanks. Okay, I think we'll manage to start a bit earlier. Just a couple words. So I represent here PyLadies Amsterdam. There is another person who is right now online with us, Julia. So hello, Julia. We run in PyLadies Amsterdam. What we do monthly workshops. Once per year or once per 2 years, we do talks. So you're happy to get specifically on our talks part. But we always try to keep it as technical as possible to make sure that you can learn something and take home with yourself. We also made this banner for the events about which we're gonna talk at the end of this evening. And these are just the pictures from our workshops. So as you see, despite the name PyLadies Amsterdam, we are open to everyone interested in Python and specific topic of the workshop. We expect them that you come in with a specific thing set up. If there are some issues with setup, we are guiding you through. And then all workshops usually have 1 to 3 exercises or more. And the majority of the workshops also have solution folders, so you can pick later and see what's going on there. And the majority of the workshops are not for beginners, so which we expect you to have at least, let's say, 1 year working with Python, or be comfortable using different classes, something like that. So yeah, I think without further ado, I think I can give floor to Joey. But before that, I want to make sure that Joey can see his own slides, because now the people on the stream seeing this screen. Just give me 1 second, and then we're moving forward, okay? Fantastic. So Joey, I think what we can do with that. Okay.
So also, unfortunately, I also have to click on it because it's got these.
I think, you know what we're going to do? I know what we're going to do. We can stop sharing. Okay. We can start sharing this. We can start sharing the whole screen, which is this. Okay, right? And then so, yeah, we can share that, and then I can make a copy of it so people can see it on the screen as well. That's the only thing. Okay. So tiny things, and we're moving forward.
I think these
no, they're two. They're the same. Yes. Yeah. So whether it's on mirror or, but we'll figure out. Just give us 1 second. You still have 4 minutes before we start, right? Okay. So I think what I can do, I can have the full. Okay. So if I'm gonna share this one.
Yeah. So
that's. But then, yes. And then I say present. That's what you see, but they don't see anything, right? And yes, fantastic. Okay. Just 1 second. I will do mirror. I will do mirror.
Sure, that's fine.
Fantastic. So now you have your slides, and now you have that, and we have it, right?
Perfect.
Okay, so let me just check the stream, and then take your seat, and then I'm just checking it, making sure that it's here and it's starting. Okay. Yes. Yeah, the people were mostly complaining that there are no sound. Okay, fantastic. They did great. Okay, folks, we moving forward. I think a short round of applause to Joy before this. Yeah, that's nice. That's nice. And then we're gonna do the longer version. So good luck,
Thank you very much. Yeah, hi, my name's Joey. I work here at PlayerUnknown Productions. I'm a machine learning researcher, and I love Python. And I use Python a lot in my work on a game that we're about to release called Prologue. And so, yeah, it's a great. Thank you everyone for coming and for the opportunity to talk about this work. And yeah. So basically, what Prologue is we're creating this survival game that we're releasing soon, as I said. And what we want is we want people to have this sort of brutal experience of trying to survive in a wilderness based on an area in the east of Germany called the Sächsische Schweiz. And we use sort of like real world data from around about that area, but augmented by our talented technical artist who works here called Remco. But basically the point is that every time you log into Prologue, you get a new chunk of land, which looks like this, that's 64 kilometers squared, and it has to be generated on your GPU at runtime. So you launch the game, and within 10 seconds, you have your new chunk of land. So when we were first approached this topic of using machine learning in games, we came up to this issue known as that we're calling the 10,000 bowls of slop issue, is that we know ML models are capable, and over the past few years, that has become clearer and clearer. So this, for example, I asked ChatGPT to generate a picture of a bowl of slop, and if you showed me this at the start of my PhD 10 years ago and said an ML model had generated this, I wouldn't believe you. Like, the fidelity is amazing. The composition, like, there's no artifacts, there's nothing weird about it. It's a bowl of slop. You can't deny that. It's even inferred that a bowl of slop should be oatmeal, which there's not necessarily any connection there, but you know, that shows an understanding of the concept of slop. But then I asked it to do the same thing 3 more times in 3 completely separate instances, and it generated 3 also completely amazing bowls of oatmeal, but they all looked essentially the same. Like, each one of these pixels is completely different to all the others, but there's no actual real difference here. If you look at these pictures, they all have the same sense about them, is basically the point. And that's the problem, is that machine learning models are not creative, and they don't want to explore the space of what slop or whatever could be. And they are sort of black boxes without levers unless you tell it to, because it's so complicated. There's so many parameters. You never really understand why it's making the decisions it's making. So that led us to this concept known as guided generation, which sort of powers, on a sort of theoretical level, all of the ML we do here, where we know that we have creative people here. We have level designers, we have tech artists, and we also know that even that also our players are creative, and that they want to be involved in the sort of act of creating. And then we also know that we have this machine learning technology which is scalable and can produce a lot of different things very, very quickly. So why don't we design these ML models to work with creative people? And so if we get sort of like a rough outline of an idea, we could make an ML model, scale that up, and produce hundreds of thousands of millions of different outputs with that singular idea. So obviously this is quite abstract, but like the idea is, you know, it could be used for a quest in a game. It could be used for, as I'll show here, like a landscape, just anything you could think of where the sort of base idea of it is we want to make something that is interesting, but we don't want it to be the same every time. So in terms of gaming, like how this can be used, games like Elden Ring, sort of like open world games, have shown us that like the verticality and the shape of the land can really impact on how a player plays the game. So you can really be guided, nudged even by the game without having to be on rails. So here, for example, there's like the opening vista of Elden Ring. It shows you that in the end, in the sort of horizon, there's this castle where you obviously want to explore it, but it's like guarded by a cliff. And then as you come closer, you say, okay, well, I can't get to the castle now, but I'll head towards that glowing thing at the bottom, and then maybe the church after that. And at no point are you being told you go in that area. There's no invisible walls. It's just sort of like showing this off to you. And then also, if you think about sort of Red Dead Redemption 2, if you come to the edge of a river, you can't just immediately go, oh, I'm just going straight over it. You think, okay, maybe I'll go further upriver, see if there's a bridge, or I'll just turn back on myself. So having these as levers to sort of guide a player can really impact their experience. So that's kind of where we're starting with guided generation and what we're doing in Prologue. So we know they're important gameplay features, and we create an ML model where an artist can draw rivers and mountain areas just like in a sketch form, and the ML will generate height maps, infinite height maps, where the broad strokes of it, the river, the mountain areas, are roughly in places you want them to be, but every single time the individual details of it are different, so you never have the same game twice. But because this is a machine learning project, we need a bunch of data, and so Python has helped us with this by this library known as PySheds, where so basically we start with these height maps, and these height maps were sort of real world data, but augmented by our tech art team. And what we need to do is we want to say, where are there credible rivers going to be in a height map such as this? So what PySheds does is it effectively goes pixel by pixel and says, where would water flow if it's in this this cell? And this leads to this sort of flow direction grid. And then it imagines you drop a bit of water, a drop of water on every single pixel, and it asks how many pixels would then drain through each pixel. So one pixel drains into this pixel, flows into this pixel, so then that one has 2. And then that one flows into this one, so that one has 3. So then by the time you get to sort of 10,000, 100,000, these are areas where water is likely to have drained into, where there's likely rivers. And so by thresholding that and extracting this, and I'm stealing this all from PySheds, none of this was my idea, so don't take it. Yeah, it's a really, really cool library, and please check it out. But we can threshold this and find these river networks where we know where everything sort of connects up to, which are most likely to be the main rivers, etc. Then what we've done internally is taken these height maps that we want to use as data, and used PySheds to extract these rivers, but not all of the rivers. And that becomes important later. We take the most main rivers, but also with some probability, just reject rivers and say, don't put them in the training data. So then we go from the height map to the river mask, and then we flip them around and we say, okay, now we want to go from the river mask to the height map. And the benefit of throwing some of those rivers away and only using the main ones is that, so you see that there are all these, oh, can you see this? Yeah, all these like sub rivers going into the main river. We get those for free when we generate the height map. So for example, here in the bottom left, here you can see that just coming up here is a main river in the land. We found that the ML model, when it generates a height map, will actually just automatically put in sub rivers into the main rivers, because it'll say, oh, well, a river this wide should need some rivers feeding into it. Which is cool, and something that we sort of like didn't sort of intend to happen, but basically shows that the ML model, despite it all being a black box and it not understanding what it's doing at all, has encoded some information about what a world should look like and what sort of rivers can do to the landscape. And then on the top right here, this can actually end up impacting gameplay, because we have these worlds where there's like an upper level, there's up a cliff, and then a lower level where sort of the river is and stuff like that. And the actual drainage of the water towards the river is what causes sort of smooth inclines, which allows players to actually climb from the lower level to the upper level, which means that players start to get a sense, which they would get from if they were sort of like hiking in the real world, that like using drainage networks, they can sort of traverse through through different elevations and up, basically. So yeah, so that's how we make the training data. But how do we actually create an ML model from this? And we use this thing called latent diffusion, which you may have heard of. Stable diffusion is a model which produces really high quality images. And sort of here I want to talk about how we use latent space and also what latent space is. So I always find whenever I'm talking about latent space that this is the perfect illustration of what it is. So basically, a bunch of researchers took hundreds of thousands of messages with emojis in and trained an ML model to say, okay, given the words that are around this emoji, what emoji should we put in here, basically? And it gave it nothing else than that. That's the only thing it was supposed to do. But it also asked for the dimensions of the vector that it stored these emojis as to be a lot smaller than you might expect. So instead of how we represent an emoji, which is like, 1,000 by 1,000 pixels with RGB values, etc., they said, okay, just give it like 100 or 1,000 numbers and represent these emojis in terms of where they should be in a text. What the ML model does is it compresses that representation of an emoji into this smaller dimensionality, but that dimensionality is then representative of what that emoji means. So for example, you have this big island of emojis that are all flags, for example, or you have this one where it's all the faces, but these faces down here are happy and these faces up here are sad. Then you have the zodiac symbols here, you have the sort of sea creatures, etc. But the idea, so despite us not having told the ML model anything about these emojis, it's managed to pick up meanings and representations of it, almost instructions. So if I have a sentence, the ML model says, okay, give me something that's a bit sad, maybe a face or like a flag, and it knows to sort of put it in, basically. So how we use this in landscapes is that we train a latent space of landscapes. So we ask the ML model to do this really strange task where we start with the full high definition height map, and we ask it to compress it down to 1/16 the size that it originally was. So the information it can have is 1/16 of its original, and then we have another system which expands it again and tries to match the original to the input to the output, which are both the same thing, which obviously seems like a stupid thing to do, but it means that the ML model learns to represent what this height map should be, basically. And you can see it like, hopefully you can see, I'm not sure if it's sort of bright enough or whether I'm just imagining it, but like you can see the structure of the latent space sort of imitates the structure of the real world space. So we have this sort of main river here and stuff like this, meaning that the latent space is actually a representation of the large scale structure of the world that it's trying to encode, basically. And as I'll show you later, that means that the decoder and the encoder are there to represent the details, basically. So now we have these two systems, which is the latent space, which represents what's the shape of the world, and the decoder, which says, okay, given that's the shape of the world, what are the details we have to apply to that world to make it actually look real? Right, and how do we do that? So then after this point, we only deal in latent space, where basically what we do is we take the final latent space version of a training data point. So that's one of the height maps that we have from Remco, and we add a bit of noise to it, and we say to the ML model, can you take that noise out for me, because I don't want there to be noise in my latent space, please. And it says, oh yeah, and it learns how to do it. It learns to say, okay, well, it looks pretty smooth around this point, but there's a bit of noise there, so I'll take that out. And then you add a bit more noise and you say, oh, can you take this noise out as well? And it's like, well, I mean, it doesn't look that much like a latent space, but yeah, I mean, I kind of sort of see what they were going for with this. Okay, I'll take that out as well. And then you do it again and you're like, I don't know. And then another step and then another step. And it's like, oh, can you find from this sort of like, can you find where we've added the noise here, please? And it says, I guess I could imagine there being a river here or like a peak here, maybe. But then so then what we end up with is we just have complete random Gaussian noise. So it started a complete Gaussian random noise, and we've asked it to learn at every step to take away that noise. So what we do is we reverse it and we say, okay, well, start at the random noise, take a bit away, take a bit away, take a bit away, take a bit away. And then we get our latent space, which means that the ML model has learned to completely imagine that there should be a latent space from just pure noise, which means that every single time it's slightly different, or very different, hopefully. And so here's sort of an example of this happening in real time. So again, we start with this random noise, and it's worth looking at this point to look at the random noise and how it looks in real space. Because if we just run this complete random noise and decode it, it looks like crap. It doesn't look like a real landscape, but the details are still there. So you still see that there are it's sort of almost erosion points along the edge of ridges. It's just sort of like on smaller scales, it kind of does look like if you're walking around, it would look a little bit like a real space, but the large scale structure is completely gone. Which is kind of what we were talking about earlier with the decoder adding detail when and the latent space being the large scale structure. So if we see also at this point we also add conditioning. So we say, okay, where have we added noise given that there should be a river here, and that's what it learns how to do basically. So then here we have it sort of step by step, taking away the noise, imagining what the latent space should look like given this conditioning, and it manages to create firstly a latent space that looks like what we want it to. It's quite smooth in areas. It's got this river area, but then decoded, it is this sort of like great, in my opinion, sort of like real space landscape with correct drainage networks, mostly with the river where we want it to be. And that is the latent space, and the latent diffusion has allowed us to have this large scale structure, and the decoder is then painting the details on top of it, essentially. And then, yeah, that was it, sorry. So then when we get to actually put this into the game, we have sort of a bank of river schematics, we call it, which are sort of the drawings of the rivers, and we can get out very different landscapes, even for one river schematic, where the details are always different, but there's also different peaks and stuff like this. And like if you played the game, if we had two schematics and you played the game 200 times, you would start to say, okay, this is getting a bit samey. But as long as we have sort of like enough schematics and that users don't get the same one too many times, they tend to like the landscapes. And even better, this is also with my colleague Remco, we've put this tool in the hands of our users. So we now ship Prologue with this for playtests. We ship Prologue with this tool where we say, oh, just draw whatever river you want, and then click this generate button. And then, as I said, this is all happening on a user's PC. The latent diffusion model is taking this river drawing and doing this latent diffusion step by step, removing noise conditioned by the river that they've drawn. And then after decoding and all of the magic that happens through the game team, which I unfortunately can't talk about at the moment, also because I don't understand how it all works, we can actually look into the game and see that we have a map with the river that we wanted, with all of the drainage patterns that we expect and stuff like this. So this has given users the ability to sort of make their levels themselves, and they have. And that's this is really over the past week, and it's actually a lot of fun seeing this being in the hand of users. So this person on the top left here has drawn their dog in as a river, which is a lot of fun. Somebody put the PlayerUnknown Productions logo. Somebody made a maze, which is amazing, and then somebody was sort of trying to imitate sort of lake and island network similar to a place nearby them, and it is actually just so cool to see them use it. And so yeah, so next steps is how do we take this latent space, and our plan as a company is we want to make sort of planet-sized worlds, and we want to move this from Prologue into so we work also on an engine called Melba, which it does render planet-sized worlds made using machine learning. It's called Project Artemis, and I could talk about it because it's very exciting, but I'm probably coming to the end of my time now. So how do we take this and we move it into planet-sized worlds? So I did this little experiment where I took two tiles here. So we have the island, and we have a completely like much higher area, which is sort of like a mountain area. And using my trained decoder, I turned this into latent space. So tile 1 turned into latent space, tile 2 turned into latent space. And I just stacked them on top of each other and then passed it through the decoder and said, what do you make of this? And obviously, because these are two completely different areas, it should like there's no reason why it should have done anything cool with it. But we found that actually on the border between these two things, it firstly had lowered the land of the mountain area such that it had made almost like a coast, but it also done things such as like widen the mouth of the river like you would find on the coast, basically. So you now have this jagged coast, and there's no latent diffusion, anything going on here. It's really just sort of like numpy.stack of these two latent spaces, and we've got this out. So the idea is, okay, well, why don't we learn to tile this latent space? So I have to press this, don't I? So we just go tile by tile, and so this is now twice as big as the latent diffusion normally does. And we say, okay, top left, generate this bit. Then with this second tile, we know that the left-hand side of it's got to look like this because we have this tile already. Can you denoise this using the conditioning such that like it looks continuous, piece by piece? And doing this one by one all the way across this latent space causes the latent diffusion model to generate a much larger map, meaning that if, like, in principle, touch wood, as long as we make it reliable, this could be as large as we wanted it to be, essentially. That we're no longer limited by the latent diffusion size because we can do this tiling. But this is all a work in progress, I'll say. And then because we're working on this cool engine called Melba, me and my colleague Paddy put this into the Melba engine, and so now we have this planet that you can draw. You can draw the river network, and it will generate a planet basically with the drainage networks as you expect and stuff like this, which is kind of fun. Yeah, and then the open questions, which if anybody wants to come and give me the answers to, that would be great. Is like, how do we do the scaling to planets? Like, can we make the decoder be local and not need to take everything into memory? And then also, like, does everything make sense in latent space, or should we pass off and start doing things in real space instead? So a lot of the work that we do is in sort of upscaling in real space. Should we do that upscaling in real space? When does it make sense in real space and latent space? And then also, like, there's always a room for procedural generation in our work. In Prologue, part of the reason Prologue looks so good is because of all of the work that the procedural generation that's done in this company. So where do these handoffs lie, and how do we make sure that it's sort of looks great on all scales, basically? And yeah, thank you so much for listening. We're hiring, importantly, so if you're interested in MLOps engineer roles, internship, or even just a speculative application, let me or Eddie know. Eddie is here, and both of us will be happy to talk about it. And yeah, also after all of the talks, if anybody wants to play Prologue, there's a few laptops through the other room, and it would be great to hear what you thought about it. And again, thank you so much for coming. I think we have a few minutes, so any questions?
So if you have questions, speak as loud as possible so the people who are online get the chance to hear it. If not, then I'm going to ask Joey use as summarizer, or I'm going to try to summarize your question.
Yes, I have a question about the river part.
Mm-hmm.
Because you said that at a certain point it was producing sub-rivers, and you didn't know where it came from.
Yeah.
Okay, so when do you say you have too many rivers?
It's a great question. And yeah, so the question was, like, when do we decide a river should be a river? When do we decide we have too many rivers? Is that sort of like a good... Yeah. Basically, that's a huge problem that me and a colleague, Janko, are both losing our hair over. And yeah, the question is when... Yeah, there's no good answer. It's a gameplay question as well, right? It's like, if the whole world has rivers everywhere, how does that impact on the players' sort of experience? But yeah, we haven't got a good answer to that yet, I would say. Yeah. Sorry.
Very non-technical question. Before just looking at it from an end user experience, what is the upside of this methodology versus traditional procedural generation from the player experience perspective?
It's a great question, and like, as an ML person, I guess I'm not best placed. Sorry, the question was, what is the benefit of using machine learning over a traditional PCG setting? I think, like, yeah, as I say, I'm an ML person less than a PCG person. One of the benefits is it got me a job in a gaming company, which I've always wanted. But I think probably a PCG person would be better answering that question than I would, because this is kind of all I've known, I'd say. So yeah, but it's a great question. Yeah.
Yeah, sorry, just like,
Oh, sorry.
Yeah, go.
So at the end, you were talking about like working on like real pixels rather than the latent space.
Mhm.
So like first, why did you pick latent space? Is it because that you want to run with these on like players' computers and it's like less intensive?
It's a great question. So what I will say is that the ML, all of us at the ML team have tried a ton of different things, and something. Sorry. Oh, sorry. The summary of the question was, why did we decide to work in latent space on some things and real space on other? And the truth is that we do work in real space for a lot of stuff. Like Preface at the moment uses real space. Even Prologue. So we do up sampling, which works in real space as well. But I think there's two points when you come to machine learning compression. One is that firstly, yeah, you can work on a smaller GPU, but also the less compressed your data structure is in ML, the more data you need to make sure that it's not overfit, basically. So we are still working in a finite data environment, like because for a million different reasons. So so yeah, that compression I think helps in that way, I would say. Exactly. Yeah. Because this, and so it's not only us using this latent diffusion, right? It's for the models that are doing really good high quality image generation. Sort of latent diffusion is a pretty state of the art concept. Yeah, no worries. Great question.
So if you draw the rivers, like those look very rough. If you sort of next to the rough shapes make like really tiny rivers, or would that also be sort of be visible in the final thing?
Yes.
Like sort of a higher detail will be like in the latency it will still retain that.
Yes, exactly. So yeah, completely. So you can see even here on the oh, sorry. The question was so sorry. On the when we're drawing rivers, can we draw smaller rivers and still see their result in the height map? Is that right? Yeah, is that a good question? Yeah. So yeah, you can see with this person's dog that they've drawn that basically there's the latent the real space that we decode in the ML is 512 by 512, but we typically say if the pixel contains any river, then count it as there. So yeah, it like I would say kind of to a degree. Yeah.
Oh yeah.
I already asked one, so I don't know.
Yeah.
Otherwise, I was curious. Like the methodology you outlined, it makes a lot of sense. It's very dramatic, like river and mountain landscapes.
Mhm.
Does it still apply if you're doing, let's say, more mild landscapes like rolling foothills or the Netherlands, right? Where there's a lot of water,
Well,
hills and all?
I always joke that I could code the Netherlands landscape simulator in about 5 minutes, right? You would just have np.ones as the sorry. The question was whether the question was this works well for dramatic landscapes. Would it work well for sort of like less dramatic landscapes like rolling hills or the Netherlands? Yeah, I'd say so. And actually, part of the reason for this is that sometimes ML models like the ball of slop thing, they err on the side of caution a lot. So a lot of guided generation is like trying to poke the ML model to say make something interesting for once. So yeah, I mean it's I'd say so. I'd say it does do that quite well.
We have online questions,
Mhm.
so you don't need to repeat it because
Okay.
it's online, so people who online can read that. So how smaller tiles are combined into a larger tile? When we can decide whether larger latent spaces is the decoded area slightly, sorry, oh my god. Okay, once again, on step number 2, I have a question on how smaller tiles are combined into a larger tile.
Mhm.
When decoding larger latent spaces, is the decoded area a sliding window for better continuity around the edges?
It's a great question. Yeah.
I can also show you just in case.
No, yeah.
Guys,
So
it's small letters, but yeah.
yes. Yeah, that's a great question. That is a really great question. And the answer is yes. But this is really sort of work that I've done over the past few weeks. So it's still lots of stuff we want to try out. I mean, like, so I'll show you this animation again. But yeah, basically the tiles are given the so in the diffusion step, the tiles are given their bordering tiles and said to fill in the gaps, basically, and make sure that the areas that they're given stay the same. But the decoder is still just like, oh, we'll throw, because we've got these massive GPUs we use for training, I just throw the entire latent space and decode it, which is probably a pretty stupid way of approaching it. So it's something that we're going to look to experiment with, and yeah. But great question, just absolutely fantastic.
We have the time for last question.
Cool. Oh, sure.
Yeah, go.
I was wondering, like, what exactly is the execution time on the generation of the terrain? Can it be like done in real time, and especially if you're looking to explore like a very big world, could you generate like chunks in a way that if the player is moving towards it, that it generates faster?
That's a really great question. The question is, yeah, the last question I finally got the hang of it. Yeah, the question is, like, how fast is the generation? Can it run it in real time at runtime, such that people can just walk in an area and then it decodes it in real time? The answer is, so I think I said runtime earlier, and that was wrong. It's at load time. So with Prologue, at least at the moment, you sort of load in, and during that loading, we're generating the terrain. But in Preface, which is our tech demo, which is available on Steam, everybody please download it. It's very cool. We actually do run ML models in real time on your laptop. So you're sort of going down into a certain area, and there's a quad tree which takes the tiles nearby and the ones that are relevant to you and runs them through an ML model. So yeah, I think, and that is done in real space. But I think it's a great question, because it's just like, how do we even think about doing latent space on that sort of scale? And I don't think it's impossible. But yeah, it's something that we're gonna have to think about, because it's a weird thing to do, basically, I think. But yeah, great question.
Thanks. I think the second round of applause for a lot of answers. Thank you so much, Joe.
Thank you so much.
Yes. Now we have a 10-minute break, and we start in 10 minutes sharp with the next speaker. Hi, Alisa.
Hello again.
Ooh, it's a lot. Wait a second, I make you slightly. And now say something. I just adjusted the sound.
Just test. Is it better now?
Okay, please, yeah, share your screen.
Mm-hmm.
And also show yourself. Fantastic. Yes. Yeah, I think that's the max that we can get for that. Okay, so now we have a short break, and we're starting in 10 minutes.
Mm-hmm.
Okay?
Yep.
So now you can, if you listen all this noise, all the happy people just going.
Perfect.
Just a second.
A bit of immersion. Why not?
Okay, I will get back to you in a second. Hey folks, we're starting in 1 minute. I'm gonna sit with you, my dear. Like, we have 1 minute to start. I think you can unmute yourself so far.
Yeah, you
So
are.
yeah. And I think folks gonna hear you. So yeah. Okay, we're starting with the second talk. Our speaker today is Alisa Dammer. She's joining us from Hamburg, Germany. So yeah, Alisa, the floor is yours.
Thank you. So, good evening. I hope you have a good time. Today, I want to give you a little bit an overview about how to, again, go back to consistency of LLMs. Like previous speaker said something in the lines that LLM does not want to create like really, really something new, but we all crave novelty and, you know, random stuff in our games to get the truly open world feeling. Yet, we all hate hallucinations, so there needs to be found a kind of in the middle ground, and this is what I want to present you today. Oops. So a little bit about me. I'm doing a lot of data science and machine learning by trade, and otherwise I'm trying to touch as many technology pieces and topics as I can, because why not? It's awesome. I have huge interest in general tracking, like health tracking, mental tracking, also gamify the shit out of it. So you got the gist. And this is also you're probably going to see in my talk. So let's go further to the expectation management. And what I'm going to talk to today about is very specific use cases in game design, mostly text-based ones, and as well as what you can do, what you should not do, and what data you need to collect and why to make sure that it stays consistent and high quality. We're also going to talk a little bit about fine-tuning of the models or approaches, architectural as well, and one expensive one, so rather novel one, how to automate all these checks as well and introduce more quality into the game. So let's get started. AI in gaming, you can use it for sort of dynamic content creation, but also you can use it in automation of the static content creation, like using the standard game design approaches, all the decision trees with the dialogues, but the dialogues can be scaled to multiple NPCs so that you can populate your world with multiple different characters instead of one within the same time. On the other hand, you can engage in quest generation, because I know a lot of players complain that especially procedural quest generation is leaving like a sour taste in your mouth, because it's always the same. Bring 10 flowers to this person, go there, bring that, but there is no variation, which again makes people lose interest. The other thing would be dynamic dialogue creation, where you have, well, not really no control, but you let your NPCs run wild and see where it goes. A new thing is multi-platform bots, where players can interact with the characters from the game, not only within the game context, but also outside on social platforms like Discord or some other Telegram chats. This definitely is serving less the game development itself, but more community building. And it requires more sophisticated approaches to make sure that the characters stay consistent, especially if you have one person to character session in game and multiple people to character in social media. This is where still I think human moderation is severely needed. Another thing would be definitely graphics and animation creation automation. This is generally not my topic at all, but just wanted to mention it. So the focus of this specific talk is static, semi-static content creation. And let's dive into more specific examples. I found 2 okay-ish rated games on Steam that claim that they are completely AI-powered. So they create a text-based world for you, and you can create basically on demand different passes and different worlds, and engage in basically every session is a new game. The biggest problem with these games, according to the responses from the users, is consistency, either within one playthrough or actually within multiple sessions. So if we want novelty, but we want consistency, what do? We need to keep an eye on what is happening, what are the responses, and what is going in really, really carefully. We also need to be aware that the evaluation metrics or different KPIs that we can create can be very different. They can be based on reference existing or no reference existing. Game design is mostly in games work with single input, no data previous set known, as well as no ground truth generally. So it's going to be a more custom metrics pretty much always, or rather composite things that you can create up to free-form evaluation from LLMs. So whenever we create anything that needs to be consistent, we also, I said ground truths, but in reality, we need a set of parameters or factors or metrics that are estimated the same way across all the different events, and so that the events can be compared, so that the chatbots or LLMs, our NPCs, also can be adjusted if needed. First level of the data that you need to consider is the limitations. The game state must be the ground truth. The mechanics and components, ideally you would give LLM an access to functions. For instance, instead of LLM to answer you with, I would like to attack this player, it should actually try to just call the action attack. You also want to have global character state, which is the character design, and then update on lore or character development. Technical stats are referring to the response itself. You can do some automatic assessment and evaluation like toxicity, length, relevance, sentiment, and other things. You can add more advanced evaluation here as well. For instance, you can add semantic relevance or similarity through either Levenstein distance, super simple, specific keywords presence, or BERT score, but we will talk a little bit later about that specifically. Additional stats that would definitely improve your player experience, but it will require an additional game design adjustments and a lot of thinking on how you want to and when you want to introduce this survey is the user engagement and user survey. Some things you can assess really fast, like the quest was created and accepted but never fulfilled, or the quest was actually straight rejected at some point, as well as later on you can ask, well, how did it in the game went? Did you like this specific thing? What do you think about this NPC? Based on these building blocks, you would like to create a huge logging system. Probably all the logs will be stored in multiple different components, but generally you would go like player input that needs to be classified by the system automatically. What is about? Is it about quest? Is it game-changing action? Is it something that concerns only this character, or is it something else? You will save the raw response, obviously, assess the previously shown technical characteristics. You can set, or you should set, different thresholds. Like, okay, this toxicity above 0.01% is not allowed. For this specific character, we are not allowing negative moods and stuff like that. So that if the threshold is failed, then you can recreate the response before providing it to the user. Relevant score in this case is maybe different things. For instance, it can be how relevant is it for the game main story, or is it a relevant score for this specific NPC, and this response is aligned with the NPC lore. Additional thing that you can collect is the automatic assessment of the player interaction with the system. For instance, on the quest, or generally you can do it for inventory, or also interaction with the characters, like what exact action was chosen. So you would use the event or log the event, check the completion or the state. Duplicate potential will refer to the concrete content, like is it about the specific item and specific action that needs to be done, or additional limitations and conditions. Novelty is how this combination was probable to be created and was already present in the playthrough or not for the player. The estimation and free input should come from the user himself. For instance, when something happens to the quest, it expired, there should be a pop-up that says, oh, this task is not available anymore. What do you think about it? Or there should be also a free input opportunity for user to provide, again, some feedback and to use that later on for fine-tuning the experience. So metrics that you can create can and should assess multiple things. First of all, we want novelty, right? So you would go for something called response novelty score, which is 1 minus average similarity over all responses. And average similarity you can assess via different methods. Very simple ones like keywords presence or Levenstein distance, BERT score if you have some smaller already pre-trained model. You can go expensive and crazy and go with LLM judgment by basically comparing the latest output with all previous outputs pairwise and asking if how close, for instance, from 1 to 100% or within -1 to 1 or from 0 to 1, whatever scaling you want to use. The or just general assessment. Do you think, based on the player's style, this would be interesting? There are problems with this approach. Because you need to save all the responses and compare it with pairwise, there is going to be a scaling problem at some point. So you might want to start cluster things, or think of other approaches like sliding window over the data points. This thing can be automated. Depends on your budget and costs and time you want to spend in. You can also try to use human in the loop to do sample-wise comparison. And again, it can be enhanced really, really well with player preference survey, where you would ask player directly, within the last 10 quests, did you have a feeling that it was interesting and variable, or rather same? What would you like to happen? Another thing that you can assess and should assess is something like quest consistency ratio. In this case, we are talking about, are quests aligned with the general game rules? Are they manageable? Do they make sense? And also, if they are aligned with the main story. The general approach is simple enough. It's the number of valid quests. By valid, I mean something that can be executed and is attempted to be executed, divided by all generated quests in percentage. The small catch here is, what are the valid quests? Because if the user doesn't feel like accepting a quest, it might be for a reason that there is an item, for instance, that he needs to give up for the side quest, but this will create a deadlock for the whole storyline. Or it can create some small soft logs. So valid in this case is a little bit of taste and is up to game designers. This can be assessed automatically. Again, it can be enhanced by the player feedback and engagement by improving or making the first part of the formula, valid quests, more complex. This is what I meant by the last point. So what do we do now once we have all the data and more? How we adjust the LLMs or anything else? Like, what do we use? Do we use big ones? Do we use small ones? How we stay consistent? There are several approaches that I split into. Simple is, you need to keep your game state, like a general game throughs, in JSON structured manner or generally structured manner, away from the prompting part. So it's either system prompt or it's outside reg system, but it needs to be queried as a source of truth. You also want to follow the normal game development with state engine that is giving LLM some functionality and abilities, but is always limiting factor. You can split events into freeform, into non-modifying and modifying events. Modifying events are quest creation, execution, that definitely changes the state of inventory, of the character, of the game itself. Then it only goes through the function calling. And if you want to add just a little bit of spice to your NPC, you can allow just chat freeform response that is non-modifying and can be left unsupervised for some part. When creating a prompt, it is really suggested to use not only positive examples, but also guidelines, like you should do this and this and this in a structured manner, as well as do not do this and this and this, and provide the fallback. For instance, if there are conditions for a certain quest creation or even specific communication unlock, then you would provide, these are the states that need to be met or conditions that need to be met. If it is not the case, fall back to, and you provide one specific opportunity what to do. Shortly here, once the chatbot or NPC is adjusted, so let's say we go with scenario that game designers are creating NPCs and then automate multiple NPC creation with LLMs. with the same approach. So it's a pipeline, and it is obviously automated on the general approach, like don't be mean, or you're a mean character, so you would prefer to do this, not that. These are your strict no-goes. These are your good sides and desires. This state of the model is then released to the players. And this is where also more architectural decisions need to be done for the game. For instance, there are two opportunities to keep the state persistent. One is RAG, and the other one is knowledge graph. Obviously, different technologies. One is mainly for the text, so it's very useful for free-form communication, for the lore, for the relationship between player and NPC, and you want to store all the sessions also there. For knowledge graph, you want to combine it with the game engine, allowing different managing the state of the game. You can use it for inventory state, quests, stuff like that. Definitely do logs, quests, tasks, everything you can. Every single thing needs to be logged, and split it into explainable, human understandable format. Do use functional APIs. You should allow LLM to do changes or to make changes to the game, but do it through this specific limited approach. You can, and you should, once you have player feedback, do the reinforcement learning from human feedback, and then adjusting or fine-tuning the model for the player. This is costly. So the question of the cost is very, very prominent, and I don't have any answer or suggestion for that. It's just the question, if you have like a chatbot per person, then you can go for this. If you have one character or a chatbot for multiple players, then probably you should be very, very careful and not approach in further optimization. Only moderators should do that. Continuous monitoring, obviously, save everything you can. One new approach, or let's say new, it's about a year old as an idea, but it is now very well researched and has. So researchers say that this is the way to go. You can use LLM as a judge, meaning the one model creates the output and the other judges it based on the game state and consistency, desired consistency or desired variability levels. There are debates if it makes sense to compare these two models, like both of them should be big, or the performance of this judgment is better when one big model creates the response, but several smaller models that are highly specialized on specific things like sentiment, like consistency and other scoring, should be the judges or like juries for the output. I do encourage you to check out these papers. They're pretty nicely written, and I think they're very interesting as well. So, conclusion, what do we need to do to make our chatbots, NPCs interesting? Do provide it with the LLM endpoint, do provide it with the access to the game state through functional APIs, but you also want to make it consistent. So you need to log every single surprise, every single interaction, as well as interactions between the NPCs if they exist and allowed in your game. Feels like game development now needs more data engineers in general, but this also opens a very interesting community building possibilities where you, as a player, create a second reality, so to say, and have your, I don't know, character, girlfriend in a relationship almost going into your real life. I don't know what to say about the cost factor consideration because it's going to be expensive. Also, you want to keep an eye on the performance of such games. So I would say it's not feasible yet to have a real-time creation or like dialogue creation and communication, but what is definitely already feasible and works well is creation of the playthrough and scenario upfront playing it through, and then so on demand with some delay. For instance, text-based roguelike, you can just put in your preferences, what style you want, what general mood, if it's a mere horror story, if it's a mystery, if it's something else like comedy style, and meaning you can have multiple playthroughs through within one game framework that will never repeat. Also, there's a consideration of if you can reuse this context or not. Again, I don't know exactly how well this might work, but this is up for debate. So this is all in a nutshell. Just a small overview of where you can go and what you can do, as well as more research and resources on simulations on evaluating consistency of different LLMs and how they are represented in the game field. Thank you.
So we have time for a couple of questions. Only one person requested a question. I would ask you to move a little bit forward so then the speaker can also hear your question. I think it would be easier. Any questions? I think everyone is still processing and evaluating the cost of processing this text. Yeah, there is a question coming. Yeah, if you want to show yourself, you can show yourself here. Yeah, go on.
So when talking about using LLMs, also thanks for the talk, it was very interesting. When talking about LLMs in games, you would never expose the LLM to the user, because that, I feel like, would give a lot of room for hacking and abusing the AI. Is that correct?
I would say, well, I think it's part of the game at some point. So, for instance, I personally see it as communication with a human-like creature or like sentient creature. And every communication is sort of a trying to exploit, like trying to understand what you are, trying to get something out of you. So I see your concern, but I think it should be and can be part of the mechanics.
Okay. Thank you.
Thank you. Any more questions? Maybe somebody was provoked by this thought. Okay, then I think we're gonna give the second round of applause, and then we're gonna move to the next 10 minutes break. Thank you so much. Yeah, sure. Go and then go back to me, yes.
I don't know.
Hey, I missed the final part that you were. Oh.
Oh, shoot. Because, sorry, the old ones.
Now I get it.
I will just give it a moment. Okay, so I will mute myself for a second, and we're gonna start soon in a couple of minutes, folks.
I mean, I'm quite used to presenting with like teams and stuff, so I don't really mind.
Okay, so now I'm sharing it. I just need to check that I'm sharing the proper thing. Did happen. To share the present. I just need to make sure basically click it through so you can see here it's like here and actually there's existence. That's fine. Or if you prefer, you can just put it.
I'll try and use both computers simultaneously. I think that might be easier.
Yeah, okay, I can just like quickly. Okay, sorry. Okay, yeah. So now it's moving. I'm just checking where it's stored on the slides, and we still have 5 minutes.
I mean, my talk itself is probably only 10 minutes, so there's room for me to like click the button. I have my notes on one computer, the slides on the other. Yeah, now I have to click through both each time.
But at least you know what's coming up, I guess.
Yeah, I've got 2 hands, otherwise it would stuck.
It's weird to present sitting down. I always stand up.
Sorry, basically the thing we use because it's such a different task. Like you said,
Saying hello to the folks who are listening to us. How many people are online? Okay.
Yeah. Okay, so we're gonna start in 2 minutes.
One time I did a talk and there was like 3 people in the room, so I expected like 3 more online, and it was like nearly 1,000. So it was like, this is boy.
Yes.
But it really changes your tone when you think about how many people you're speaking to.
Focus on us. Of course, focus on those who are online. But
Yeah.
this also will be recorded. So.
Yeah.
Okay, the only one thing, I will do this a little bit like that. Just check it.
That's another interesting question. And like I was working on a project in university where we're trying to guide the decision process also using non-reference images as a signal. Oh, so like like just what we did was we used the diffusion we do, and what we did was we also used the input to go to the clip encoder as well.
Okay, folks, we are coming to the last part of our event today. Before, of course, networking and chatting to each other. So let me introduce the person whose name I learned to pronounce, I guess, from the 3rd attempt. So Siân, welcome, Dr. Siân Brooke. Yeah, I think she will have more to say to you than me. I just need to find a way where. Okay, I'm gonna go just here. Okay, thank you.
All right. So thank you for having me. I'm Dr. Siân Brooke, and I'm an assistant professor here in Amsterdam at the Informatics Institute at UvA. And my work focuses quite a lot on the communities around Python. I research hackathons, I look at IDEs, like I do a lot around like open source collaboration. And of course, like all of us, I start moving into, well, how does AI fit into that? What does it mean when you have a coding assistant that has learned all of its interaction norms from Stack Overflow? And then how does it speak to the average new coder, right? And so I do a lot of work like this, and also in general, looking at what happens when we use GenAI in space X, not actually X, because that would be terrible, but in general. And so I look at inclusion along multiple dimensions. And so here today, I'm talking about how GenAI is shaping game development and why inclusion must be part of that conversation. And where can things go wrong when we start throwing GenAI problems to make the fastest growing newest games without thinking about the pitfalls that history can very much show us. Now, this isn't just about what GenAI can do, and it's about what it tends to reproduce, its training data that we've heard a lot about today, and who it can leave out in terms of its representation in games. So today I will walk us through some scenarios from research, but also some real-world examples of bias and harm, focusing on gender, neurodiversity, queer and trans identities, and how these work into game development. I'll also have to click 2 laptops at the same time, which is bad for my dyspraxia brain, but we'll give it a go. So before we get into some examples, I just wanted to offer a quick content note. Okay, clicking 2 at the same time doesn't work. So this presentation focusing on inclusion also includes examples of not being so inclusive, such as harassment, discrimination, and death threats that have occurred in tech and gaming. And so I want you to really keep this in mind. I think it's worth saying whenever I'm giving more of these public-facing talks. I'll say, so with this in mind, let's clarify what GenAI is and what it can create. So when I say GenAI, I mean tools like large language models and image generation models that are looking at producing new content based on its training data. And we've heard how they can be used in generating landscapes, in NPC dialogue, and how they are used across a range of purposes. But these also can include quite toxic elements. So in the talk before, we spoke about some of these text-based AI-driven games. And some examples of these text-based driven games have, because their training data is a lot of internet, it's Reddit, right? It's all of these places online. They have leaned towards generating scenarios which have involved queer characters being assaulted just because of the data that they are learning from, right? One example was AI Jundun, which I don't think is available on Steam anymore. And so these tools do scale creativity, but they also can scale bias if we're not looking at what they're producing and having some human in the loop. And these biases aren't new, as whenever I'm talking about anything to do with research, right? Like sexism wasn't invented with ChatGPT-3, like it existed much before. And they echo long-standing problems within game culture as well. So Gamergate, which I'm sure seems like a long time ago now, was a coordinated online harassment campaign that began in 2014 and also kicked off my doctoral thesis, targeting women, queer people, and marginalized voices in gaming under the banner of ethics in journalism. And what it really did is legitimize abuse, normalize doxing, rape threats, and mass harassment, especially against women developers and critics. Now, it didn't just harm individuals, but it creates an idea of gaming culture that promotes gatekeeping and fear-based exclusion. And so how does this link to GenAI, right, in 2014? Well, the same internet forums, memes, and toxic content that fueled Gamergate are part of the data and the culture in which we're deploying GenAI into games. So when we see misogyny or transphobia in AI-generated dialogue or imagery, it's not random, right? It's something that's resurfacing through the training data. And so to see this in action, let's think about how biases can show up in GenAI generated avatars. So you may remember this trend from a few years ago of, well, maybe a year or two ago, of people generating like gaming avatars based on their images, right? And so tools like Stable Diffusion, when women would put portraits of themselves in it, like this example here, would result in hypersexualized depictions, even with very neutral prompts accompanying the images. Now, this wasn't an accident, but it reflected how feminine bodies are represented online and how this data then shapes GenAI outputs. Meanwhile, men in the same sort of experiments would be more likely to shown in role-based professions rather than these hypersexualized images. And this isn't an this is a reinforcement of structural inequalities, but it's made to look more neutral by having this diversity of output. Now, this pattern doesn't stop just with images, but it runs through each stage of a game development pipeline. So much like the speaker before, I think about where can we put GenAI in video games, and where does that lead to potential sources of bias or exclusion in the development process. Now, GenAI isn't just for dialogue or character art, but it's woven through the entire development process. We could think about tools like Midjourney for concept art or speculative design of game landscapes, LLMs just for quest writing, even if it's not powering the actual text, right? But using it to draft some examples. And the focus of my research so often is the use of GitHub Copilot in coding and AI mods for player behavior that are already in use. Now, this makes bias a system level issue, something that needs to be tackled culturally and widely, rather than thinking about it at the level of individual models. A level designer using GenAI, for example, may unintentionally reproduce one type of landscape across all games, because that is the landscape that we have the most data on. So there's an element of homogeneity that may result in very European-looking countries appearing in games. So the problem isn't just with what GenAI creates, but where and how we use it without this reflection, when we get caught up in the hype without thinking about what this means. And so while GenAI brings impressive speed and scale, those benefits can come at a real human cost. So it does allow small teams to do big things and very fast, but it doesn't remove bias. It can hide it. It can even amplify it. And the more that we rely on this sort of content, the easier it becomes to miss how stereotypes and norms are being reproduced under the surface that might then pop up a bit later down the story. And if no one is looking for these patterns, or there isn't like someone feeling responsible for them because it's about speed, it's about move fast and break things, right? Then the things that can be broken really do matter. And so if GenAI lets us move faster, we must consider what we're trying to move towards. And that's a question that I think we should consider when developing, is where are we going? So let's think about how this plays out in character design, and especially how women are visually represented. Now, this isn't something that's particularly new, right? This is memed to death. This game culture already having this long-standing problem with the way that women are represented, thinking I'd rather just look at something nice, right? If I'm playing a game in the third person, think this meme of the iron bikini armor that is impractical, highly sexualized, and it's really down to this like very archine view of like the male gaze. So when GenAI takes over asset generation, it doesn't challenge this, it doubles down, right? This is an idea of something that we see in games that can be popular, and without intervention, this could be the training data that we're using, right? They're having these teeny weeny iron bikinis. And so we can also see in some research how procedural storytelling experiments in academia, often at ChaiPlay, which is a great conference for this sort of stuff, it has shown how NPCs can also reproduce gender-based roles, with male characters being cast as warriors and female NPCs being seen as healers. And this is something that GenAI learns when it's reproducing characters. Now, these aren't just like visual cliches, but they shape how players learn who holds on to power in the game, how to navigate the world, and really form part of the logic of the game. Now, it's not just gender that GenAI struggles with, but it also struggles with queer and trans representation, often erasing them entirely, except in some notable exceptions. So large language models, we train them to often produce the most likely answer, right? And that is what is considered normal, what is shaped by dominant cultural understandings. That's why ChatGPT always sounds so confident, right? Because we associate that confidence with the right answer. And so that's why these models tend to portray people of certain identity groups in certain ways, because it's confident of these sort of stereotypes. In one study, prompts to ChatGPT around gay men led to stereotyped, outdated portrayals, and in other stories with non-binary protagonists came out fragmented and vague. And so when using GenAI for characters, it can often rely on these tropes, these stereotypes, because they're a lot more narrow and they're seen as a lot more predictable, right? There's less room for this loss of the story if you're going with a very one-dimensional stereotype. These models don't fundamentally understand the data, right? We know that they're remixing the information that they already have. And when the training data is biased, the output will be biased too. And I mean biased in the social sense, not the statistical. And because there is no single author to often hold accountable with these representations, these narratives get a pass. And so when it comes to players themselves, GenAI can deepen exclusion, especially for neurodivergent players. So an element of my work also looks at how gender and neurodivergency intersect in terms of interacting with different technology. And so when we're thinking about gaming systems, neurodivergent players can engage with game systems differently, right? Missing nonverbal cues, having more of a propensity towards sensory overload, or struggling with rapid pacing, or even having difficult understanding what is the expected next step. But Gen AI-driven systems that adapt difficulty or behavior cues rarely account for this difference, this variation in people. And so without design input from neurodiverse users or developers who are aware of these needs, this system risks misunderstanding or even punishing different player styles. We should be using AI to leverage the idea of personalization in terms of players' experience and thinking about a game that adapts what people actually want and how they think. Research shows, for example, that autistic players of video games are often misread by AI-based moderation tools in massive multiplayer online games or within in-game logic scenarios, and this can really compound a feeling of exclusion. As NPCs become more dynamic and conversational, as we saw in the talk earlier, then this risk of bias and exclusion based on these different characteristics grow even more immediate. So earlier we were talking about NPCs, and I just wanted to add some caveats to that on the realm of inclusion and exclusion. So Gen AI powered NPCs can engage in real-time conversation. They can be so valuable in creating immersive and unpredictable gameplay. But when models are geared by user prompts, they can really be stilled into harmful outputs. And this was one of the questions that was raised earlier. Without robust moderation, these systems can become tools for abuse, especially in multiplayer or live stream games. Pretty much any sort of learning technology from Tay by Microsoft in like 2011 has become, from user input, some sort of like quite hate speech tweeting machine. And so this is not something that is new at all, but we still don't really have a way of making sure that we don't have these constant inputs into the learning models that we are creating. So without moderation, we really need to think about, well, what safeguards can we build in from the ground up? And the more responsive the AI, the more intelligent it seems to be, the more urgent there is a need for safeguards. And that's why we need to think not just about the content we're generating, but also about how AI can be used as an intervention, how it can be used to prevent harm in the first place. So AI doesn't need to necessarily respond to harm once it exists. It can also anticipate and de-escalate it. And here I'm talking about the sort of moderation that exists on Discord streams or in, I don't know, RuneScape was one of the other ones I can really think of. And Ubisoft, for example, has tested an in-game AI that has suggested calming prompts when players showed sign of frustration, trying to de-escalate a situation. However, a lot of academic work has shown that sometimes this can actually result in escalating situations, and based on the identity of an avatar. So say if we had an avatar that was female saying like de-escalating AI prompts, people are less likely to comply, right, than if it was a male-coded avatar. And so these are all really important social dynamics that we need to think about when having these tools as multi-layered social phenomena. So proactive systems, if designed well, could act like digital bystanders, nudging players before toxicity erupts. But we really need to think about where player agency is and not relying on AI to protect people from themselves. But this must be tuned with care and designed with diverse behavioral norms in mind. As I said, there is a range of norms, and so we shouldn't try and work towards a singular stereotype or an idea of who is on these forums, but should work for diversity. So then, this sounds complicated. How do we move towards this kind of care and intentionality in Gen AI design? So unfortunately, inclusion doesn't happen by accident, which is also good because then I wouldn't have a job. It requires active design. So we can't rely on this idea that programming or computer science is a meritocracy. And so all of the good will just rise to the top and then everything will be equal. It actually requires us to be really intentional with what we're building and not being an afterthought, right? Think about how we've seen any game blow up, right, when it has some really bad design afterwards. It was released too early, or something like Cyberpunk, right, when it's just like a bit buggy. Or if something has like a massive morality or ethical scandal, right, built after it's released. When we build inclusion into this process, we are also in a way mitigating or aware of some of these harms that can come later down the line, right? I was thinking earlier about your landscape prompt. What if when people drew something, right, it was fed back into the training data that then could randomly generate more landscapes? If you let people draw random things, you can think of some things they're going to draw, right? Like there is a common denominator of what people will draw. And then what if that was then randomly generated into the landscapes with more players because everyone kept drawing it, right? And so it's thinking about how can you do that so then someone doesn't go, oh, that's the game where everyone made like dick mountains, right? So it's really like thinking about this at that sort of stage as well. So we need to think about this as a regular and ongoing process. Dealing with bias is not something that we fix once, we do once, we look at it, we say it's fine, we move on. But it's something that we keep working on and using to make any game or experience better. We should think about transparency, thinking about how models are built and fine-tuned. So then if there are any alterations that need to be made later, it then doesn't become too technically arduous of a task. And we need to think about moderation tools and how we can account for some of humans' behaviors in online ways to not have games be weaponized for a particular group. So ultimately, it's not about fixing problems. It's about building systems that reflect the people who play. So Gen AI is reshaping how games are made, generating characters, balancing systems, moderating communities, but tools are only as fair as what we are baking into them. If we don't critically engage with this system, we essentially risk scaling up exclusions, making it faster, making it more inevitable. But when we design with intention, with reflection, with feedback, with the user testing of multiple groups, we can make games that are expansive, imaginative, and fair. The tech is already powerful, but what matters is what we choose to deal with it. So finally, what does this actually mean for developers, right? It's very easy for an academic to come in and just say, make it fair, but what does that actually involve? So I think one of the biggest themes about making something fair is to have explainable AI or XAI where we keep humans in the loop, right? This is one of the most simple steps that we can take. And there is a great paper that is at the start of the bibliography slides I have for this that talks about an explainable AI framework for accessing character diversity in generative outputs. And so it breaks down visual traits. And so I have a summary here of like the different avenues that you can go down. So think about this building very strongly from the previous talk, thinking about the ways that we can consider diversity in character development, where we can allow for change, where we can say absolutely not. And then we can refine, tweak, iterate, reassess. And the key is that you don't really need to be an expert in AI ethics to use this sort of system. You just need to think about talking things through with different diverse groups who use the game. It's a methodology in academia called participatory design or design justice, with this idea that you include marginalized groups within a design process. And then in this way, inclusion becomes part of the workflow, not just an afterthought. So thank you so much for listening. Today, we talked a bit more about how GenAI is reshaping game development and thinking about, hopefully, where you can include ethics in some of this process. And I really want to think about intentional design, about when we're developing in a process where we're going and where we want the end result to look like and what we don't want it to look like. And so, yeah, I would love to hear your thoughts or questions or, yeah, anything else that you might think of. Thank you. There's a bibliography in case you want to check my references.
Yeah, thanks for your talk. It was really interesting. Yeah, like I think one thing that you mentioned was that bias usually, like, often starts from the data.
Mm-hmm.
How do you think it's a good way to tackle this? Are we supposed to de-bias the data? Are we supposed to create new data sets that are like not biased, or what's a way to tackle this problem?
Yeah. So the God, I can't think and speak. So the question was, how do we essentially deal with biases in training data, right? Do we de-bias the training data or generate new data? And out of those options, I would say yes. There is, you can de-bias training data. So I think it's, if you know what use you're going to put that training data to, then it's actually not really that much of a time intensive process, right? There is even like out of the box libraries, especially in Python, that do a pretty good job in terms of like NLP. So say, for example, if you wanted to do it in terms of like character dialogue, then that would be like a reasonably simple task, because then you would be de-biasing either in the training data, or you can do it at a later stage, or both in order. You could then also have your tailor-made data sets, which is generally probably a better way to go, I would think. But it all depends on the specific output, like, unfortunately, like how much variation do you want? But you don't have to de-bias the entire, like, if you can be really specific in exactly what you are trying to use that model for, then de-biasing it is actually a relatively simple task. If that makes sense. I can give you an example. That would help. No? Okay. So there's a great paper on word embeddings that looks at the difference between particular professions and the distance, which is very much like the latent space that we were talking about earlier, between gendered terms and profession terms, right? And it's called man is to computer programmer what women is to homemaker, right? And so the idea is that, this is where I start drawing on boards, is that you have the same distance, right, essentially, between this profession and this gender, and then this gender and this profession, right? And if you're plotting them, you can essentially minus the bias from the space, right? And so something like that, when you're working with words, is then like not super hard to do. That paper is like 2016, right? Like this stuff has been around for quite a while. And so if we know what we're doing, image generation then becomes a little bit more tricky.
I was thinking of it much just when I asked the question.
Yeah. most of the papers I see on like image generation just go, oh no, it was sexist, and then they stop.
Like, okay, so it's also maybe like a human in the loop,
Yeah, or
kind of thing.
Yeah, or just like having something that asks more questions or is slower, right? Like it's often about what are you trying to I don't do too much of image generation myself, apart from getting people to generate images and then do an ethical reflection on it. But it's a newer technology, right? So then, yeah. You can always debias a prompt, I guess, and then feed that in and then see what you get. But there's sort of like slightly more fudging ways around it.
Cool. Thanks.
Nice.
Any other?
I actually work a lot on gender biases in Python as well.
Have you met, political discussions regarding this topic? Like, have you run into some, let's say, groups, for example, of parents that wouldn't like their children to be, let's say, have completely unbiased LLM and so on? What kind of like thought goes into this?
I don't really understand the question. What do you mean by unbiased? So wouldn't want like would think it was too cuddly almost? Would think it was too woke?
That like the LLM considers, let's say, everything perfectly normal, everything from both extremes of, I don't know, normalcy to something that would be considered, let's say, extreme by some Christian groups, for example. So in a way, like this thing becomes political. It has the potential to become political. I'm just wondering on your thoughts of this, like.
So the question was essentially around, and correct me if I'm wrong, the idea of if you are totally debiasing, that you're getting AI to make some value judgments, right, and become political. So my response to that is it's already political, right? In reproducing stereotypes, in reproducing racism, in deciding to be confident, it is already inherently political, right? We can't say that like a stereotype of a woman as a homemaker is not political, right? Because that's fundamentally a conservative value, right? So if we were debiasing to remove that stereotype, we are still being political, right? But I am by training a political philosopher. And so anything that involves people, interactions, and power fundamentally is politics to me. And so if you are interacting with ChatGPT and you say, can you give me like a depiction of the perfect society, right? Even
which is the family, let's say.
Of the perfect family, right? That is political, right? If we had a model that only produced particularly like white heteronormative 2 adults, 2 kids, and a Labrador, right? That is making a very political statement, but one that's quite rooted in very sort of like fundamentalist, quite like Christian, very sort of like Western European values, right? But then if we were to go the other way and then end up with some of the mistakes like Microsoft did, where we debias it to such an extreme, it just shows us like a Berlin polycule every time, right? Reality is actually somewhere in the middle of this, right? And so it's saying like, we want this diversity of representations. We want it to think about like different ways that people can produce many different colors of slop, right? Rather than just recreating these same images again. I think it's very easy to think of when we want claims for equality and inclusion that it's political, right? Because that takes energy and then we can dismiss it as being political. But actually choosing to do nothing most of the time and choosing to keep things the way they are and choosing to go with existing power structures is also political. So yeah, that would be my response.
Thank you. Thank you so much. Another round
of
applause. I would ask PyData Amsterdam colleagues come to the stage. Yeah.
Do I leave?
Close.
Yeah.
Thank you so much. Thank you. I'm gonna move this here. I'm gonna open our slides. So there are a couple of announcements that is coming, and then we're gonna stop the stream, and then we're gonna move to the right direction. Okay. Okay, fantastic. So yes, thank you, which is nice. And then the only question to picking up our slides again. Okay.
I think it's over there. Google Drive.
Yeah, I see it. Yes,
Oh.
yes. Yep. And I'm just gonna go to the right slide. So now I'm making sure that you're sharing the proper one. So that's you saw just a second ago. Okay, so once again, the final round of applause for all the speakers of the day. Thank you so much. Also, thank you for coming there. So what's next? That's the question. Today, we're almost at the end of this stream, and then we have a couple of minutes further to mingle. So what's next with PyData Amsterdam? So on the 26th of August, we're going to have, this is a high probability that it's going to be a hybrid event. It would be something related to, or whether MLOps or machine learning engineering, we get back to you when we properly structured better for you. Then we also going to be a part of events that PyData Amsterdam folks going to talk about that. And then we decided that one event in September is not enough for us. We also want to have another workshop. So on the 30th of September, we have an online workshop, and it would be dedicated more to data engineering focus. And it would be about basically learning how to create data models with Python dbt core and use it Snowflake basically as a sink. So that's about us. So ladies, talk about your next event.
Yeah, but I also wanted just to thank you all for bearing with us until 8 p.m. Also, the speakers were really passionate, and I loved how we started with the game design, went to the limitations and risk of the games, and also we had even the solutions how to mitigate those risks. And as Una said, we have a next meetup. It's in Xavier in Amsterdam. We don't have much more details, but we have a speaker which is from Google, and the topic will be about data agents. Yeah, it's with Women in AI, Benelux. So yeah, welcome everyone.
The event is for everyone, okay?
Yes. Not it's all inclusive. So and also, as we are PyData Amsterdam, we are hosting annual PyData conference. It will be in next one. Yeah. So it will be 24th and 26th of September. Here you can scan the QR code and you can get super early bird ticket. And we have also a video of the teaser video. So let's watch it.
Hope to see you all there. Okay.
Yeah.
Don't forget the tickets.
And you can see us again there. We're going to have a community booth. So if you have questions, you can go back and chat with us. And I think we still have more things to come. Oh, no, I think it's enough, right? Yeah, so if you're interested, like our GitHub all over the place. So all workshops that we are running, it's all, let's say, I would say open source, and the majority of the workshops do have a MIT license, so you feel free to use them in a way you want, but please keep those who created this workshop as the creators of the workshop, of course. We usually post everything on Meetup. That's probably how you ended up here. And if we allowed to do the video records, as we were allowed to do it today, we also keep track of all our events on the YouTube. So each GitHub repo has a link to the video if we were allowed to record it, so you can rewatch it. We also try to add as much as possible. It's still like hands-on thing, manual thing. We try to add a timeline, so which makes the video more easy for you to navigate and sync with the workshops. And in case you come across the workshop which has some issues or bugs, or because some, for example, attributes or methods were deprecated, please feel free to open a pull request. We'll be always happy to merge it, of course, if it works. So this is where you can find us, and I'm just going to do this.
And this is where you can find us, PyData Amsterdam.
Okay, fantastic. Thank you so much. With this, we close in the stream now, and then it's time to you to mingle. And remember, at 9 o'clock, we have to leave the building. Otherwise, we don't want an alarm. We had a tiny alarm with a coffee machine today when it decided to clean itself. So sorry for the background noises. Thank you so much, and I conclude the stream by that.
And if it's not clear, PyData Amsterdam is celebrating 10 years anniversary, so super special edition.